Today's lesson, we are looking at some of the basics of the graphs of polynomial functions. So here we're going to look at, we're just going to have sketches of 4 different types of polynomials. So the first one, so 2x squared minus 4x plus 1. So there we have a quadratic. And we're just going to sketch a graph of a quadratic. You should know what a quadratic looks like. It's a parabola. So, in a parabola, let's see, what's the degree of a quadratic? It's a 2, and they often cross the x-axis 2 times. And that's the maximum number that it can cross. So those are zeros. So there's a maximum number of zeros of 2. It matches the degree. Now technically we can have less than 2. You could have a parabola that touches once. Or we could also have a parabola that never touches, has no real zeros. These would have those imaginary solutions, but there's a maximum of 2. Okay, turning points then. That is here, I'm decreasing, and then I have this point where it increases. So I have 1 turning point. So the turning point is just simply 1 less than your degree. Okay, so now let's look at a cubic. Y equals x to the third minus 5x squared plus 3x plus 4. Let's sketch a graph of this cubic. So this graph goes up, it comes back down, it goes back up. So the highest degree is 3. That means it has a maximum of 3 zeros. Now, cubics can have less than 3. They can't have more than 3. A cubic function could just cross 1 time. But it cannot cross 2 times because that's going to cause a problem. You cross twice, you go up, you come back down, but we have to come back up for it to be a cubic. And then number of turning points, 1 less than 3, which is 2. All right, let's do a quartic. So y equals x to the 4th minus 5x squared plus 2. So this graph would look like this. It's going to go down, it's going to go up, it's going to go down, it's going to go up. And this example is actually, it's symmetric about the y-axis. They're not all symmetric, perfect like that. But this one will have a maximum of 4 zeros. You can have less, you just can't have more. So a quadratic, or a quartic, sometimes can even look like a quadratic. Sometimes it looks very similar to a quadratic. Or it could go up, down, it could go up higher and then back down and never cross. It could cross twice, so there's lots of examples of quartics. And then turning points, 1 less is 3. And by turning point, think about those critical points right there. It's where it's changing direction. So it changes direction from increasing to decreasing, decreasing to increasing, increasing to decreasing. Okay, last one. You can probably guess what this is going to look like. Y equals is kind of a long function that I chose for whatever reason. X to the 5th minus 5x to the 4th plus 5x to the 3rd plus lots of 5s. 5x squared minus 6x minus 1. Not a big deal if you get that all on there or not. We're just kind of getting ideas. Okay, a quintic. So this one is going to go up, back down, up a little bit, back down, and then up again. Quintic is going to have a maximum of 5 possible zeros. And then 1 less, 4 turning points. But remember, you can have less. Some quintics look like cubics. So the odd functions can mimic each other, and then the even functions can mimic each other. Okay, same idea. We are just going to do some basic sketches. In our assignment, we're going to actually graph and get all the exact points that we can, but right now we're just kind of getting ideas. So here is, I'm going to have a polynomial, an even degree, and the leading coefficient is positive. So y equals, here's my leading coefficient, that's positive, and then x to the fourth, that's my degree, is even. And I'm not even going to write the rest of the polynomial. Just imagine that there's more going on to that polynomial. What we're going to do is, here's just a sketch of what it could look like. One thing I want you to be aware of is what's called end behavior. It's going to point up in both directions. And then here, this is the bottom point. You can't get further bottom than that. That's called an absolute minimum point. But it's going to go up forever, so there is no absolute maximum. But now with these extra little curves, we call these relative mins and relative max. So this is meeting a maximum point. It's this critical point, but it's not the absolute max, so we call it a relative max. Relative max. And then this is called a relative min. All right, so now we're going to have an even degree again, but this time the leading coefficient is negative. So let's say y equals negative 3 x to the fourth, and let's say there's a lot left of this polynomial, but we're just going to write the leading term. So in theory, this could look something like this. So this one, the end behavior, it'll be pointing down in both directions. So here, what we would call this has an absolute max, but there is no absolute minimum. And then these points, critical points, it's a relative max, your relative min. Okay, so now let's look at an odd degree, leading coefficient back to positive. So y equals 5x to the third. So there's odd, this is positive. So a graph could look like, oh, sorry, I was going to do the dots again just to show that I'm, in theory, would be adding things to this polynomial, but we're just looking, it's just the first term that matters. So in theory, I could have a polynomial that looks like this. So all of a sudden, when we have an odd degree, our arrows are in opposite directions, and there is no absolute max or min. And then here we would have a relative max and a relative min. Okay, last example, odd degree, leading coefficient is negative. So y equals, here's my leading coefficient. We still have an odd degree, let's do to the fifth power. And in theory, there'd be more coming after this leading term. But what we're going to do, that leading term, what it's going to do is flip these arrows. So it's actually going to be going up this way. I'm going to go down, up, and down. So because this was a fifth degree, I added more curves. So because this is negative, here I've got this and this. Same idea though, because it's odd, there is no absolute max or min. And then I have all of these relative max and relative min. So both of these points are critical points. They're both considered a relative max. And then both of these points here would be a relative min. So there's your full video. I'm just kind of looking at the basics of a polynomial function. Our goal this year is to just, if I give you a polynomial, you can tell me some basic information about the graph. And there you go. Good luck with your lesson.